go ahead and introduce yourself?
Oh. So my name is Kong Yu Chen. I'm product manager from Pivotal. And today I'm going to talk about how to integrate Pivotal Greenplum with Hadoop, Spark, and GemFire. Before we start the conversation about presentation, I just want to tell you that I'll be talking a bit about forward statement. I'll be talking about roadmap items. So this is just a disclaimer that things that I'll be talking about is a plan in progress. So things may change as time changes over time. So today's talk, I want to talk about a couple of things. And let's start with the Greenplum ecosystem. Greenplum ecosystem allows you to access structured and unstructured data. Structured data would be the columns and the rows that you have within your tables. Unstructured data would be somewhat JSON, Avro, or even files that are semi-unstructured data. And all this data could be located in different data sources. And for today's conversation, I'm going to focus on Hadoop, GemFire, and Spark ecosystem. And it's pretty important because we want to enable Greenplum users to be able to load the data, analyze the data within Greenplum, and in some cases, even export the data back to other ecosystems. The first item that I would like to talk about is using this PXF, Platform Extension Framework, to access Hadoop ecosystem. I'll be talking about the architecture of this PXF, followed by the examples of using it. Let's start with this simple use case. On the left-hand side, you have your business analytics. A business guy who wants to get some data, and based on the data itself, want to run some analytics out of those results and generate a report. But your data are located in different places. Let me introduce the concept of data lakes. Data lakes are a place where you get the data from different data sources, and you just dump all this data to this data lake. And some of the data lakes that I can talk about in Hadoop world is Hortonworks, Cloudera, or MapRa, or even other Hadoop disciplines. Those data are sort of structured and unstructured. And those data are just being collected there until you need to use it. But if you want to run analytics on all those data, which is on your data lakes, you probably want to use Greenplum because Greenplum can run analytics using SQL-compliant, standard SQL-compliant statements, and it can also perform queries using complex queries, provide you complex data analysis in this case. And what we'll be asking is that how could I run this query in Greenplum? The key importance is being able to load the data at high speed. So with this key concept, we're going to talk about how we're going to parallelize data transfer from data lakes into Greenplum. And once you run some query within Greenplum, you can generate your analytics and create some reports. I want to highlight another key importance is data lakes could contain cold data. Cold data are data that you store for a long period of time. In some cases, you may have older data that you may not use often. You may even back it up to external cold storage that is low cost and is most effective use of your resource. But if you want the data to run, you want to run data on analytics, you want to load the data within Greenplum and run analytics within Greenplum. After it's done, you want to reduce the data because putting the data in Greenplum is utilizing the resource that you may not use often. So since we talk about parallelizing data load from Hadoop's file system, I'm just going to introduce you to Platform Extension Framework, which is the way that Greenplum is loading the data from Hadoop file system. So Greenplum itself is an MPP database, massively parallel processing database. Within it, it has a master database and different segment hosts. Segment hosts are physical machines, and within segment hosts, you have segment process running on each segment host. And what we like to do is show we parallelize data transfer from Hadoop file system. We have a PXF, our daemon itself, that runs on the segment host. The segment host itself knows how to communicate to Hadoop file system. PXF has capability to load Hadoop file system Java API in this case, And through the Java API, we can contact Hadoop file system name node to figure out where the data are located. The data are located in different sections of data nodes. And once the data is being located, PXF knows how to get the data by parallelizing the query from segment host to the data nodes. So parallelism is very important because only through parallelism you can load large amount of data in the shortest time frame. And what do I mean by extensible? Extensible is because we are using this thing called Platform Extension Framework. The Platform Extension Framework allows you as a developer or users to develop your own plugins, and through the you can communicate to external data source. In this case, we are just talking about Hadoop file system. You could communicate to another database. You could communicate to other system as long as you know how to write this PXF plugin. Query efficiency. The reason why I mentioned query efficiency is because in order to load the data in parallel form, we need to break the data in multiple fragments, and the fragments will be loaded by each segment. So imagine you have 1 million records, and you break it down to 10 fragments, and each fragment is loaded by different process. So 10 workers will speed up the process of loading large amount of data. So that's what I meant by query efficiency. So we talk about the architecture of PXF. Now, what I would like to show you is a simple example. How would you load the data using the query language itself? This is a simple example of creating external table. The external table concept means that you're trying to retrieve data from some third-party sources. In this case, we are just focusing on PXF. So therefore, you have to use the location PXF in this context. Every external table that you have the concept of readable or writable. Readable is used when you're trying to read data from third-party data sources. Writable is when you want to write data into third-party data sources. Within the table, you create columns, like any typical tables. You have a location that tells me PXF protocol talks to Hadoop file system, a particular path. Hadoop file system has a path itself, similar to a file system that you need to find. Within each PXF framework, we talk about this concept of plugin. And the keyword that we are using in this case is called profile. And the profile is the capability that allows you to read different file format. In this case, HDFS text simple is a simple text format. HDFS text multi is a multi-line text format. We also have Afro format and other file format as well. I don't have space to display all the file format that we can load. Since we can load this file format, and each format itself may have different data format within the data sources, each data format may be text, CSV, or even custom format. What do we have here? Sure.
Is the PXF daemon running on every segment instance?
PXF daemon is running on each segment host. And segment host is the physical machine. So a physical machine may have 4 or 5 segment process. So that depends. Okay. Thank you. Just now I just explained the format. Let's jump into some real example. So if you look at this, you can create external table. There's no readable or writable. And in this case, by default, is readable. And you create a table with this table format. And I did mention to you that in order to use PXF, you have to use the PXF protocol in this case. And PXF protocol, you need to reference to the file system within Hadoop file system. In this case, is this simple text file. And we are using a text simple profile that allows you to load a text simple profile. And we can configure it to load different type of format. In this case, I want to be specific. This is a text file with a text format. With this delimiter, in this case, is a comma. So what we have here is a PXF framework that you can customize and design to load different formats. That's what you want. With the capability of loading any format that you want. A more complex example will be okay. And most Hadoop users would have a Hive table. And Hive table allows you to create a table using the tools that you're being provided by Hive. In this case, you use Hive shell, and you create a table with a Parquet format with this following columns. And since you already create this table in Hive, would you want to, if you want to load this set of data, you want to load it in as simple as possible. And the way we have created this external table is that it allows you to reference a Hive table when you specify location, default Hive, and this allows you to reference a Hive table. Therefore, you do not need to know the path of the files because those files are located within the Hive catalog. And what you do need to do is specify a profile called Hive. And we know that we can communicate to a Hive table, a Hive system, and we retrieve the metadata of that Hive files, and through that we can load those data. So the follow-up question will be, since we talk about read, let's talk about write. Is it very different? No, the basic concept is that you need to create external table, but you need to specify a writable. Creating an external table doesn't, that will be loaded. Create external table is trying to specify which are the tables that you're trying to retrieve from a third-party data source. In this case, we are trying to get the data of a simple text format. And once you create this table, the data won't be loaded into this table until you specify insertion. And in this case, this example below shows that when you create in your Postgres or your Greenplum console, you start inserting the data to this external table, and internally, PXF would write data in a parallel form to all those Hive, Hadoop file system. So we talk about read and write, and we talk about PXF framework being able to support different profiles. So this is just an example of the profiles that we support. So by default, you probably want to use any Hadoop file system, and there are different formats supported by Hadoop file system. But for most people, they will have created a table within Hadoop file system, and they would have used Hive. And the nice thing about PXF is that we being able to reference Hive table with different format, minimizing the effort for you to configure it. We also support HBase, and we also get a lot of a community who are interested to develop their own PXF profiles. And we have Cassandra, JDBC, and other profiles as well. In fact, we have GemFire profiles as well. So all these profiles is helpful because as more people develop profiles, you can leverage it. So we talk about PXF. I'm just going to tell you what's next. What are we going to work on since we talk about read, write? The next common question that I get is that now write features, I would like to have secure access by using user impersonation. I would like to use Kerberos. I would like to make sure that the access to this PXF service is secure. That's a common question that most people ask once you have read and write feature. And in some cases, people are asking me about performance. So these are the two items that we are going to look into for the next 6 months to a year. Secure the Hadoop file system by using Kerberos or user impersonation. We can also develop new profiles depending on the feedback and which are the profiles that most people are using. And in this example, I reference Kafka as well as GemFire. Any questions? Okay. So we talk about PXF, and what I'm going to talk about is a Pivotal Greenplum-Spark Connector. This is a different ecosystem. This is a Spark ecosystem. So a typical Spark user is different from a Greenplum user. There are different set of users, but all of them are dealing with data. A Spark user might be using a Spark clusters, and those are in-memory processing. But Spark itself has no data it needs to retrieve the data from some other data source. So in this case, you could retrieve data from Greenplum by using standard JDBC driver. But the downside to that, if you use a standard JDBC driver, it is loading the data through Greenplum master. It's not a parallel processing system. It means that it's going to be slower if you use a standard JDBC driver. A typical use case is that you have data scientists who love to use Spark, and the data is in between Greenplum, so they need to load the data into the Spark environment, run some interactive analysis to get some data points, and create a model. And once they create a model, they say, hey, why don't I write some of these results back to Greenplum? But to do that right now is that if you use JDBC connector, it just takes too much time. And that's where we start talking about Greenplum-Spark Connector. So Greenplum itself is an MPP system, which means that there's a master node, there's a segment nodes. Segment nodes has all the data split up, partitioned by certain distribution. And in this case, I'm just demonstrating there's 3 segments. I didn't show the master node. But the segment itself has the data. And what we have is a connector that parallelizes the data transfer between Greenplum cluster and Spark cluster. And between the Spark cluster, there's a driver, there's a worker, and the worker could be hundreds of workers. It doesn't need to be one-to-one mapping between Spark and Greenplum. For simplicity's sake, I just show you one-to-one mapping. And what we have here is a connector that is smart enough to break the data, partition the data into small piecemeal, and those data are parallelized data transfer from Greenplum to Spark. Spark has a constraint, which is that each Spark environment has partitions of data, and each partition data has 2 GB of limitation. So we figure out a way to partition data into small chunks and parallelize the data transfer from Greenplum to Spark. Let's look at a simple example. How would you use this Spark connector? It's pretty simple. You go through a Spark shell, and you have our connector. You just need to pass the jar location to the Spark shell by using this option --jar. And once you have the jar loaded, you run into a Spark shell. You want to verify that the Spark shell has loaded the jar. And the easiest way is just run the import class, and it'll show you whether the class has been imported in the Spark shell. Next, the simplicity of our driver is that you just need to specify the JDBC URL, and this is a username and password to access the database, followed by the table. One thing that's interesting, there's a column called partition column, because we need to figure out a way to partition the data from Greenplum to Spark. We need to divide the data into partitions. And one way to partition the data is that you give us a column that's either a serial number or integer, allows us to partition the data into rows, and through the partition of data, we can transfer the data into Spark environment. So this follow-up example demonstrates that this is a Spark data frame, and Spark data frame needs to have access to our driver by specifying spark.read format, and this is a driver name. And we pass in this option that's pre-created previously, and once you click load, we initialize the loading of the data, but it's not being triggered until you start triggering the action. Now, I've just demonstrated to you that how easy is it to write a Spark program with our connector. The next feature that most people are looking for is how can I optimize the data transfer from Greenplum to Spark. And previously, the example that I show you, it loads the entire table. So the follow-up feature is to add this feature called projection, which means that you want to select a subset of columns from Greenplum. And this subset of data should be filtered from Greenplum processing system such that we only select this set of columns. In this case, these are the following columns that we want to extract from Greenplum to Spark. So this will speed up the processing because you limit the set of columns. And this GBDF is just a Spark data frame, and once you print schema, you get the result of the schema.
We have another question.
Sure.
Can you explain more on why partition while load to Spark? This means while loading to Spark? Why partition?
Why partition while loading to Spark?
Hmm.
Does that make sense?
Not really. It's a.
We can ask him to clarify
Yep.
that.
Can you also clarify? I'd be happy to talk about it.
Sure. Keep going.
Yep. So previously I mentioned that you have a way to filter the columns to limit the set of data. Column is one way of filtering. The next feature that you want is predicate pushdown. You want to filter the rows that you're interested, but you want to filter the rows on Greenplum section. You don't want to filter it on Spark, because once you filter it on Greenplum's cluster, it limits the data that's being transferred from Greenplum to Spark. So in this example, what it shows is that the data frame is be able to select a set of columns as well as filter the data set by rows. In this case, cancer is equal 1 and float month is equal 12. Limiting the set of data that you retrieve from Greenplum, you can speed up the data transfer because you get a subset of data. So talk about using the Greenplum connector, Greenplum-Spark Connector. And these are a couple of features that we are looking into to enhance the connector. Similarly, once you have features of reading the data, next thing people will be asking, can I secure the access to this data? And Kerberos is actually a standard way of securing the data by ensuring that the right enterprise user has access to the data. So supporting Kerberos will be very important. And the current connector itself uses public schema. A typical enterprise company may choose to use non-public schema because they want to lock down the schema. Therefore, that's why we are looking into ways to support non-public schema as well. I did mention that we only support reading the data from Greenplum to Spark. So obviously, the next feature that we need to work on is parallelizing the data transfer from Spark back into Greenplum. And that will open up a whole range of use cases. For example, doing ETL streaming in Spark before loading the data back into Greenplum.
So Bana Online is asking if you could elaborate on partitioning in Spark.
Okay. So the partitioning of data, it depends on the data from Greenplum, right? So you have 1 million rows, and you want to load the data into the Spark workers. And let's just say there are 3 Spark workers. So you have 1 million rows, and let's say you want divided by 3. So maybe you have like divided by 3. On an average, you probably have 3 million rows per partition. So you want to transfer 3 million rows from a Greenplum segment to a Spark worker. But how would you divide by 3? You need to figure out what is the column to decide to partition on. So what we recommend is that choosing the option called partition column, providing a column that we can partition the set of data, which is specified here. And in this case, we are using a partition column with a serial number, a column called ID, which allows you to partition a set of data. The question? Thank you. So we talk about Hadoop, we talk about Spark. Obviously, we're going to talk about GemFire as well. Pivotal has GemFire, which is in-memory data grid that scales to millions of requests at sub-milliseconds. And now we're going to talk about GemFire with Greenplum Connector. This is a very unusual use case where you have Greenplum, which is your data warehouse. It stores all your data, and you generate the analytics reports that you want. But those data being generated, such as your analytics, need to be used by applications, such as your web applications, your customer-facing applications. And you do not want those customer applications to access your data warehouse. Data warehouse is not designed to scale to millions of requests. So what we're trying to do is that build in a connector that transfers data between GemFire into Greenplum, because GemFire is designed to cache large volume of data, serve large amount of data to millions of requests in sub-milliseconds. So the connector itself here is transferring data from Greenplum to GemFire. And in some cases, you may want the data from GemFire into Greenplum. So on the left-hand side, you can say you are transferring data, analytics data from Greenplum to GemFire. If you want to transfer data from GemFire to Greenplum, you might be doing a high-speed parallel ETL processing. As you can see on the right side of this presentation, you can see there's a warm and there's a hot. Hot means data that needs to be accessed frequently. Large amount of data, large amount of requests need to be accessed. Warm in a sense that not as many requests is required. So what we have built is a connector that allows you to transfer data in a bidirectional form. So let's talk a bit about use cases. I did mention a bit about some example. So one example is that you have a consumer application, such as a web application, financial application, healthcare applications. Those applications need to serve to your customer. And you do not want them to access your data warehouse. Your data warehouse would have important data like analytics, but also has all your raw data in a database. So how would you get those analytics to be served to your consumer? So one way is that you get your data within Greenplum to be stored and analyzed. You could be using Matlit to run some machine learning algorithms. Therefore, it generates some result of the machine learnings. In this case, it could be a recommendation. And those recommendations need to be served to the users. So how will you serve the user? Is that get the data out of Greenplum into GemFire. Another use case is that you want to get large amount of data into Greenplum. And those data are coming from different data sources. A typical way would be writing the data into a file system, generate large amount of logs, and use an ETL tool to load the data from files into Greenplum. That's a typical use case. But you want to do it fast manner, you might want to get the data in memory. Memory is about 1,000 times faster than writing the file into a file system. So with this GemFire itself, you can write the data into memory. In fact, you can write some processing library to process the data, transform the data, and once the data is transformed in memory, which is very, very fast, you could use our connector to load the data into Greenplum at high speed. So we talk a bit about the connector. I'm just going to give you a flavor of how do you use it. It's pretty simple. GemFire itself has a console. And through the GemFire gfish console, you can run a command to import the data. In this case, importing the data means getting the data from Greenplum tables into GemFire. GemFire uses a concept called region, which is equivalent to a table. But the region itself is in memory, so it can serve the content to large amount of users. It's very simple. What you need to do is that we define a mapping between a table to a region, And you just run this operation called import GBDB, and you just tell them which region needs to be imported from Greenplum. The use case is that, as I mentioned, you want to get the data from Greenplum into GemFire such that application can access GemFire. Use case would be customer dashboard, recommendation system, even e-commerce site. And what you're leveraging is GemFire's capability to scale to millions of requests at low latency. And now you have a hybrid system that scales horizontally and vertically because you have spread the workload across GemFire and Greenplum. Question?
Question from Jacques. What kind of performance have you seen when running against external data? And is there any kind of limitation on the size of the data that comes back?
Can you repeat the question?
Sure, yeah. What kind of performance have you seen when running against external data?
What I'm not clear is the data coming into Greenplum or going out of Greenplum? So I do have some data, but I'm not, I can give you some rough numbers. We have some experiment where we want 300 to 500,000 requests going into GemFire, and that scales in sub-milliseconds because what you have is that you need to scale by having large amount of GemFire in memory regions. This is an example of 3, but you can have multiple GemFire in a cluster, and they partition the data in memory, so you can hold all your data in memory. As you need more user who needs to access this GemFire, you just scale by adding more GemFire nodes. The data transfer from Greenplum to GemFire, it depends. It depends on the size of the cluster of GemFire and Greenplum. So that's why I can't give you a specific number. We talk about import. Obviously, the next option will be export. Export, I did mention that the concept export is getting the data from GemFire into Greenplum. And the typical use case is that you want to load the data at high speed. For example, Internet of Things create a lot of messages, and those messages needs to be processed before loading into your data warehouse. And since GemFire is running in memory data grid, it be able to load the data at high speed because it's not writing data into the files. You can also write processing mechanism to transform the data and reformat the data or consolidate the data before transferring the data back into Greenplum. So that allows you to stream large amount of volume of data into Greenplum. And once you get the data into Greenplum, you could start using your Greenplum capability of parallel processing to generate analytics. We talk about import, which is pretty simple. Export is a bit more complex because we want to cater to different use cases. So as specified previously, there's a way that you map a region to a Greenplum table. But the way you export the data from GemFire into Greenplum, there are different options. There are about 4 different options. And the reason why we have 4 different options is to optimize the data transfer from GemFire into Greenplum. So the first one, we upsert, which means that we'll check whether a data array exists in Greenplum before we insert the data. Insert all, where we don't check for whether the data exists or not. We just insert the data immediately into Greenplum, assuming there's no collision. Insert missing means that we'll insert only the rows that doesn't exist within Greenplum table. And updates, which means that we'll update the rows that have changes. So the option itself allows you to customize to whatever use case that you want, depend the set of data that you have on GemFire and how your tables are being created within Greenplum. And last and not least is once you import the data from GemFire, you might want to remove the data from GemFire. That's why we added this feature called remove all entries after you run the export operation. So this is just as simple as running a gfish command in our gfish shell, a GemFire shell, where you just use this option, which speed up the processing of data, and you don't have to trigger the data transfer by writing some operation or running a cron job. What we want to do is that as GemFire get a large amount of data, it would periodically trigger on its own and transfer the data from GemFire into Greenplum, either by a number of rows that is added to GemFire or based on time that you need to flush the data from GemFire into Greenplum. Go ahead, yeah.
Unless I'm misunderstanding, it seems like Greenplum is mostly useful for people who have a huge amount of data to process. For someone who is only, going by running SQL to analyze data, he or she might not need Greenplum. Is that a fair assessment?
It is.
Can you repeat the question?
Sure. The question is that Greenplum is not designed for someone who just want to run a SQL query on a single machine.
Yeah.
Is that one?
Small amount.
Small amount data. Yeah. Yes, you're right. It's designed to scale massively. Terabytes, gigabytes of data, right? And that's why Greenplum doesn't run on one single machine. There's a master node, and there's also segments, and you can run to hundreds of segments, such that you can process large amount of data simultaneously. So it's not a typical user who would use it, but if you are a data warehouse user in a large company or you have large amount of data, then you would use it because a simple database would never work for you because you can't load all data into a single machine. Yeah, thank you. So with that, I'd like to thank everyone who attended the session, whether you're online or on site. I just want to leave it a few words that we talk a bit about a couple of things: Hadoop, accessing Hadoop file system using PXF. We talk about Spark Connector, being able to access Spark ecosystem. And we also talk about GemFire, which is a pivotal product, allows you to get the data in and out of GemFire. With that, anyone has questions, I'm happy to answer your questions right now. Yes, that's a good question. We do have a GemFire PXF, and it's being tested, but we haven't certified to work with our PXF yet. Once we certify and tested it, we'll include it into our PXF binary. Go ahead.
So in terms of security right now, there is no authentication between Hadoop and Greenplum, right?
You could use whatever mechanism which is the user, and you could configure the user that is being accessing the Hadoop file system. That's why the next option that people are asking for is Kerberos, because they want to limit it to a different group of users.
Right.
Yeah.
We need the authorization.
Exactly. Okay. You could use the option to encrypt it. We work with different partners, and you could use some of the features to encrypt it. You could also encrypt it before you load the data into Greenplum. And obviously, you might want to encrypt only the sensitive data because you want to perform analytics on those data, right? Yeah. Yeah. So there's nothing stopping you from using any security tools to build, to secure the file system, secure the columns, the fields before you load the data, or you could get the data out and encrypt those data as well. Yeah. Okay. Thank you. Thank you.